So in the past tutorial, we looked at binary classification and multi-class classification. So in this one, we are going to look at multi-label and multi-output classification. This is so we are going to use MNIST dataset where we have handwritten digits and we are trying to recognize what those numbers are. So multi-label, unlike multi-class, is you are trying to predict two things at a time. For example, I can choose two conditions. An odd number, is the number odd? Is the number bigger than, let's say, 7? So that you have two values and each of them will return out a number. So the output is going to be 2. So that's a multi-label. And then multi-output, I think I can show you with an example below, but let's focus on this multi-label. So initially we will set up our environment. You can look at other videos what these are, and then you fetch MNIST dataset from using this fetch open ML, and you have X and Y, the data, as well as target, and this is about 70,000 records. So you can see about 70,000 records, and each of these values are represents a pixel value. There are 28 by 28, each image is 28 by 28 pixels, so you have 784 values, and you can see those values are here. And this is an example image for the first record. And then if you look at the amount of missing data, there is actually nothing, so we don't have to do any transformations. Then the statistical summary is that, so the values, I think the maximum value is 254 and minimum value is 0. So if you, here I'm showing multiple images, which will be example if you are doing error analysis, but in this case this code helps you to display multiple images in a row. So first we split training rows into 5,000. I'm taking only 5,000 because some of these algorithms actually take a long time to run. In fact, when I use 20,000 or 70,000, this Jupyter notebook failed. So I will discuss a little bit about how to use multi-thread in the later query. So for example, we are here creating a multi-label here. This is how we have a white train. Remember, white train is these numbers anywhere from 1 to 0 to 9, and then we are converting this into, we are saying if it is greater than 1, then we are saying it's a large value, and if it's if the ratio %2 is 1, if it's odd, we are capturing it. So we are creating a NP array and we are calling it as a multi-label. So this one will create an array of arrays, and each array inside it will have two values. One is whether it's large or not, whether it's odd or not. So we have multiple ways of handling this, but let's look at SKlearn to see how these are handled. So this is the API from SKlearn, and you can see we have multi-class classification. This is what we looked at before, and here what we are looking at is multi-label, and there are there is one for classifier and also one for regression, and one for label and multi-output. So you can see these are all possible algorithms for, let's go, these are for multi-class and these are for multi-label. And you can see not everything can be applied for multi-label, and these algorithms can do multi-label. So I'm using these. So I tried using decision tree. It was taking a little bit longer, but it was okay. This worked okay. And then now I'm using random forest classifier. So and for if you want to do multi-class, multi-output, then this is what it is. But let's look at one of these in execution. So here I took a random forest classifier and I'm fitting the X train and then Y multi-label. Remember, my multi-label is an array of arrays, and we can just fit it the way this particular NumPy array. and for the sake of predicting, I'm taking two values. One is actually 9 and the other one is 5. So 5 is odd, so this should be true, and 9 is odd and large, so both of them should be true. So that's what it's printing, so it is able to recognize what these are. So if you want to do cross validation, like the previous ones, we can still do cross validations and also cross validation prediction. So we have these are the codes that can do. So you can see that it actually doing in the cross validation, because the fold is 3, it is giving the accuracy of 90, 92 and 0.90, which is pretty good. And then cross validation prediction, it is scoring each of the value for the, in a way, I guess predicting it's predicting X train. So, and then I'm trying to use this Y prediction here. I'm printing the Y prediction. You can see these are the values that it print out. So this is so we are outputting two values here at once, and that's a multi-label. So the methods that you need to remember are these. These can do it. Some algorithms like k nearest neighbor are very time consuming. So I did not attempt to use it, but random forest classifier and decision tree classifier are okay. So the other one is multi-output classification. So this one is very tricky one. So I could not run this because even when I'm using all my processors, for some reason this particular program is hanging, because I think there are too many features. So maybe this dataset is not ideal for running it, but let me explain what this is. So you can what the input looks like. So the train, the X data is going to be the modified X. So what I'm doing is I'm taking X train, which is a row of 784 values, and I'm adding random noise to it. So I'm taking anywhere between 0 and 100 and adding noise, right? So this is a modified tree, and I'm saying the true X train, which is unmodified, is my Y. So this also has 784 values. So in a way, I'm my X has 784 values, and my Y also has 784 values. So we are trying to predict these Y values by using X. So this there can be a debate, like whether it's really classification or actually a regression. So this multi-output can fall into both of them. But the idea is that we are trying to predict multiple values. We are also inputting multiple values here. So this is in a way, for at least for this method and decision tree classifier, it was very tough for this computer, which is pretty decent 32 GB RAM and probably 16 threads I can run from. But it's taking too long. So the end job number jobs is equal to -1. If you give this one, it will try to use multi-threads. So this is an option that I did not use before, but if you want to make it faster, not every algorithm has this option. If you have this option, you can use it, because most computers have at least 3-4 threads these days. So I did not run these, but because it's taking too long, but you can test it out on your own data set. So this ends multi-output classification video. And for the next steps, I think I discussed a lot more detail in the previous video.